Hello friends, in this video we are going to discuss a numerical of previous GATE question. In this given numerical, it is written that consider a material X which has a band gap of 1 electron volt and material Y with a band gap of 5 electron volt at T equals to 300 K, that is at room temperature. Calculate the ratio of the carrier concentration of the material Y to X if both have exactly the same properties except different band gap energy at T equals to 300 K. Now we know that the carrier concentration Ni square is related by the equation A0 T to the power 3 exponential minus Eg0 divided by Kt, where Eg0 is the band gap of the material at temperature equals to 0 K. Now for material X, it is given that the band gap is about 1 electron volt, so we can write Ni X square is equals to A0 T to the power 3 e to the power or exponential minus 1 by, and the Kt value at the room temperature is given by 26 millivolt, so we can write 0.026. Similarly, for the material Y, we can write that intrinsic carrier concentration of Y whole square is equals to A0 T to the power 3 exponential, and the band gap is given by 5 electron volt divided by 0.026. So this is the concentration of carriers in the material Y and material X at room temperature. Now we have to find the ratio of the carrier concentration of the materials Y to X. That means we have to find Ni Y or Ni X square, that can be written as 3.032 into 10 to the power minus 84, and Nix will be 1.987 into 10 to the power minus 17. So we can write, after doing the calculation, we can write Niy by Nix is equals to 3.9 into 10 to the power minus 34. So this is the ratio of the carrier concentration between the Y material and the X material. So this is all about the numerical. Thank you.